In this last MATLAB introduction video, we will focus on a very important topic, namely floating point arithmetic, and this has implications for how one writes numerical algorithms to solve different kinds of problems and so on. Although we will not be delving into great details, you should look it up, and this video will give you at least an overview of the surprises one might expect, the surprises one might encounter when you work with floating points on any computer. And as always, I must draw your attention to how floating points are represented, right. You can always have some interesting, right. So, oops, 0.1 plus 0.2 minus 0.3 is not 0. Welcome to floating point world, right. So, if I add 1 plus a very small number, it will give me something. If I add 1 plus, it will give me 1, right. So, when does this change? There is something known as machine epsilon, and this is typically 2 to the minus 52 on most computers, most modern computers, it is 2 to the minus 52, right. So, this is the smallest distance between two variables on the two numbers on the computer's number line, right. In a real number line, you have infinitely many numbers between any two numbers, but a computer's number line is basically discrete, right. So, how does the number line look like? So, how many different floats can you store on a computer? So, if you have a 32-bit representation, how many integers can you store?
So, minus 52 is for 64-bit, right?
Minus 52 is for 64-bit.
Minus 23.
How many integers can you store in 64 bits? Oops. How many integers can you store in 64 bits? This is not a trick question, it is basically 2 to the 64. Typically 2 to the sorry, it's is that right? Yeah. Yeah. These are basically the numbers you store. What about floats in 64 bits? How many floats can you store?
So, left side, the negative line is 2 power 32 integers, the positive line is 2 power 32 integers. If you add this 2 into 2 power 32, which is not 2 power 64, 2 into 2 power 32 is 2 power 33. I think it will be minus 2 power 63 to
Sorry, 63, yeah. This should have been 31 for, no, this is 63. Yeah. So, how many floats in 64 bit. This is actually the easiest to think of.
2 power minus 52 to
2 to the 64 floats. If you have 64 bits, you can say, represent 64 different numbers using the 64 bits. As simple as that, right? Whether those binary numbers represent integers or floats or whatever else depends upon the, how it's encoded and so on, if you have a standard. So, there is something known as, which I think everybody should try to quickly look at. The IEEE 754 standard. Of the IEEE 754 floating point standard. This basically says that every number is represented as 1 plus f into 2 to the e. And so, every number is actually represented as some f comma e, right. And the values, the maximum values of e and all of that vary depending upon how many bits you are using and so on. So, in 64 you can, there is a particular set of numbers and so on. I think it is worth understanding this, because the first thing you need to know is that because you have only 2 to the 64 bits, you are compressing all numbers between minus infinity and plus infinity to a discrete number line. It is supposed to be continuous, right?
but 2 power 64 is very big, right?
264 is big, but you do not have every number there. So, you can't. So, let us look at some interesting things here. What is epsilon? Epsilon is this very small number, 2 to the minus 52. Can I compute epsilon by 100? Well, certainly not. If epsilon by 100 were 0, then you can never say g is 6.6734 into 10 to the into 1 e minus 20.
3 no
Gravitational constant 34.
34.
Right. So, you need those small numbers to be represented. So, basically you do not have a uniform number line. The number line increases in resolution in some places, decreases in resolution in some places. Obviously, I can't add one E10 plus G minus 1 E10 will be 0, but 1 E10 minus 1 E10 plus G will be G. So, addition is no longer associative. Welcome to floating point arithmetic, right. A plus B plus C is not the same as A plus B plus C. So, these are some of the things you need to be wary of. Why is this important? This is mostly not important for us. It is not important when you look at network biology, it is not important when you look at constraint based modeling, it becomes very important when you look at ODE solving. ODE solving, you will have all kinds of weird things when you use solvers, and these numerical inaccuracies will blow up and so on. So, you need to be quite careful with this. And in general, if you are doing any numerical computation, you should never compare if two floats are equals. You should not say, let us say A equals 0.1 plus 0.2, B equals 0.3. You should not ever say A equals B. It says A is not equal to B. You should always check if abs A minus B less than epsilon. very good, right. And you often do not use something as low as epsilon, you will use a smaller number like 1e minus 6 or something like that. So, what is therefore EPS? So, EPS of EPS on MATLAB is a cool quantity. It is the smallest number when added to a number will make it different. So, it basically gives you the spacing of floating point numbers, and this spacing is not uniform.
So if we add e power minus 324 to 0, the value will change.
Yes. So, 0 plus EPS 0 nope. This is the smallest number, white by 2 into 1e16 so 1e16 plus 1 is 1e16 plus 2 makes it different from 1e16. Interesting scale, that is the IEEE notation that people came up with. This is to make sure that you maximize the number of possible computations. You also have some special floats, nan, inf, minus inf, these are all nan is not a number. One by 0, sorry, not 1 by 0, 0 by 0, indeterminate quantities, log minus 1, oh wait, here it goes to complex. So, okay, I think this is about what I wanted to cover. So, I hope you got a quick, very quick introduction to MATLAB. So, I think the most important things to know are logical indexing and ways to not use, think of ways to not use loops in your MATLAB code. So, I hope today you had a very interesting introduction to floating point arithmetic, and it will prompt you to go and read a little more about these interesting topics. In the next video, we will go back to graph theory and we will start with the history of graph theory and the different types of graphs.